sometimes, because of time restrictions, I have to tell you the rules and just say to me, or say to you, trust me. And you do. You do a good job of that. Because you know I'm not going to lead you astray by telling you false rules and such, right? But sometimes, like today, where we have a good class period to talk about the properties, I can let you figure them out yourselves. Okay, so that's what we're going to do today. I'm going to get you guys to figure out these properties, well, I would say by yourself, except I'm still going to be writing. Okay? So, for this activity, change the settings on your calculator so that all answers round to the nearest tenth. Or you can actually use your brain and let your brain round to the nearest tenth. Everybody okay with that? Okay. So, someone please tell me what the log of 5 is. Oh, can I teach you something about your calculator real fast? Somebody hand me a calculator. Thank you. Here's your calculator, yes? See log? Right there? How am I going to be able to press log? Control, and then 10 to the x, right? So when I press that, look where my cursor is. Where's my cursor? In the base, right? Do we know what base we're using here in this problem? What base does this problem have? How do you know it's log base 10? It's an understood 10, right? There's not a base written, so it's an understood 10. Do you remember that? Okay? But here's the cool thing about how smart these calculators are. I'm going to skip the base, and I'm just going to put log of 5. Did I put anything for the base? But watch what the calculator does when I press enter. I didn't put anything for the base, did I? No, it knows also that log base 10 is the common log. So if all I put is log of 5, it knows that I'm talking about base 10. Okay? So what is log 5? 0.7, right? Again, because it asked us to round to the nearest tenth. So 0.7. So what if we do log of 50? 1.7. Oops, 1.7. And then log of 100. Time out, time out. Don't press it in your calculator. If you already did, you zip it. Okay? Because we're going to figure this one out without a calculator. Because we are smart. Smarter than the calculator. What base does this have? 10, right? So what if I rewrote it in exponential form? 10 to some power equals 100. 10 to what power equals 100? 2. So what is the log of 100 equal? 2. Now prove it to yourselves in your calculator that you are smart enough to do that by yourself. Oh my gosh, you are. Okay? Now we're going to use these 3 values for these problems down here. Okay? We're going to refer back up to those 3 values. So first of all, somebody please evaluate for me the log of 5,000. Say it again. 3.7. Okay? Now I'm going to step just to the left here just for a second. How could I rewrite log of 5,000 in terms of 5, 50, and 100? Does that make sense? Is 50 times 100 the same as log of 5,000? Okay, right? Now step over here to the right for just a second, and I want you to rewrite 3.7 in terms of 0.7, 1.7, and 2. How could I rewrite those to make it be 3.7? 1.7 plus 2, right? Is 1.7 plus 2 equal to 3.7? Okay, we'll come back to that in just a second. Just keep that in mind. Somebody please tell me what the log of 500 is. 2.7? Okay. How could I rewrite it, the log, as a product of 5, 50, or 100. And not just necessarily product. I didn't mean to try to trick you. So 5 times 100, log of 5 times 100. You okay with that so far? Okay. How could I rewrite 2.7 as 0.7, 1.7, and 2? 0.7 plus 2. Okay. What about log of 250? What is the log of 250? 2.4? How could we rewrite that in terms of 5, 50, and 100? Log of 5 times 50? Okay. How could I rewrite 2.4 with these three? 0.7 plus 1.7? Okay. What about log of 20? Say again? 1.3. How could I rewrite log of 20 using those three numbers? Very good. 100 divided by 5. Isn't that 20? Okay. How could I rewrite 1.3 as something to do with these three numbers? Yeah. 2 minus 0.7, right? Okay. What's the value of the log of 2? 0.3. Okay. How could I rewrite log of 2 using these three numbers? 100 divided by 50. Okay. How could I rewrite 0.3? 2 minus 1.7. Okay. Good. I knew what you meant. What about log of 10? 1. So I could do log of 50 divided by 5. And how could I rewrite 1? 1.7 minus 0.7. Okay. This says what patterns occur and what rules can you develop. Well, I purposely didn't talk about the rules as we went because now I want to go back and look at where all these numbers came from. Okay? These were the problems, right? These were the original problems. Okay? On this side, we tried to rewrite what was in the argument as either a product or in this case a quotient of these three numbers, right? And on this side, it turned out we wrote what the value was either as a sum or a difference of these three numbers. I didn't tell you how to do it. I just said, how can we make this number from these three numbers, right? You guys figured out that it was a sum or a difference, right? Now, I want you to try to prepare yourself to have your mind be blown. Are you ready? You said to me that the log of 500, we'll just start at this one because it's a random one to choose from. You told me that the log of 500 was the log of 5 times 100. Do you still agree with that? What value is the log of 5? 0.7. What value is the log of 100? 2. What's 0.7 plus 2? 2.7. Look at the log of 5,000. They already told it was the log of 50 times 100. What's the value of the log of 50? 1.7. What's the value of the log of 100? 2. Look at this one. The log of 20, we said was 1.3 because that's what our calculator told us. But we can rewrite the log of 20 to be the log of 100 divided by 5. What's the log of 100? 2. What's the log of 5? 0.7. What's 2 minus 0.7? Oh my goodness. Do you see any patterns? Can you verbalize any patterns for me? What did I do with these two numbers in the argument? I multiplied them. What ended up happening with the value of the logs? Added them. Is that true for everyone? What did I do with these two numbers in the argument? Multiplied. What did I do with these two? What did I do with these two numbers in the argument? Multiply. What did I do with these two? Add them. So if I'm multiplying two values inside the logarithm, inside the argument, what do I do with the value of the logs? I add them, right? So can I change it a little bit into math vocabulary? Do you mind? The logarithm of a product equals the sum of each logarithm. Does that make sense? The logarithm of a product, taking the logarithm of a product, equals the sum of each individual logarithm. I guess I could have put individual right there. You can if you want, if you think that might help. So using good math terms, what's the second pattern that you see? So the logarithm of a quotient equals the difference of each logarithm. Good. Questions? Now, in a second, I'm going to show you how it looks in like a formula type thing, so don't worry about that yet. Let's just get the patterns down. Okay? Okay for that? And let's look at another table with more patterns, different patterns. Okay? Look for the pattern in the table below. I think this is funny because it's not really a table, but whatever. They didn't ask me, right? Okay. So the log of 5 squared, does that equal log of 25? Are those two things equal statements? Okay. Somebody please tell me what the log of 25 is. 1.4. What? Yes, please. Okay, so somebody please tell me what the log of 5 to the third or log of 125. 2.8. 2.1, sorry. Is that better? Does that look like a 1-ish? Fat one. Pleasantly plump one. I'm sorry, I don't mean to offend you. Log of 5 to the fourth, which is the same as log of 625. Guess what that one is? 2.8. Yeah. Okay. What about log of 5 to the fifth, or log of 3,125? 3.5. And what about log to the sixth, which is 15,625? 4.2. Okay? How does each answer compare with log of 5, which is about 0.7? How does this compare to 0.7? Say it again. That's close. I think some of you know the answer. I think some of you have even said it, but with the arrow on it's hard to hear. So from 0.7 to 1.4, we multiply by 2. How is 2.1 related then to 0.7? Multiply by 3. What about 2.8? How does that compare to 0.7? Multiply by 4. Anybody starting to see a pattern? What's the next one? Times 5. 1 times 6. Okay. What's the pattern in the table? I can't hear you. I'm sorry. The exponent becomes a what? A multiplier of the logarithm? You okay with that? The exponent becomes a multiplier of the logarithm. Okay. Okay so far? Then let's talk specifically about what it looks like formula-wise. Okay? I think the formula-wise thing will be a little bit easier since you already know what the math stuff looks like. Okay? The first one says log base b of x times y equals what? What's happening when I'm multiplying inside the argument? The sum, right? So it looks like this. Log base b of x plus log base b of y. Ooh, that's a weird looking y. Don't judge my y, please. And what it says as a sentence of explanation, the log of a product is equal to the sum of the logs of the arguments. Does that make sense? All that vocabulary, does that make sense? I think I just said vocabulary. That's not really a word, you know that, right? Okay. Vocabulary. All right. So what about the next property? Log base b of x minus log base b of y. Excellent. What the heck is up with my y's today? Sorry. You can judge that one if you want. That was really not good. The log of a quotient is equal to the difference. Excellent. Of the logs of the arguments. Okay so far? What's the next one? What happens to the exponent? Becomes a multiplier. Where? Here. P log base b of x. This comes down front as a multiplier. Does that make sense? The log of a number raised to a power is the same as the power times the log of the argument. See how the power is acting as a multiplier? It's the power times the log. Yeah? Okay. There's two special log properties that really are related to this one we just talked about that will make our life a lot easier if we can remember them. Okay? And for some weird reason they put this one first and then this one. But because this is my classroom, we're going to talk about this one first. Okay? log base b of b. This is where the base and the argument are the same. Okay? This is one of the special properties. You ready? If I were to rewrite this in exponential form, here's an example. Log base 2 of 2 equals x. If I rewrote that in exponential form, the base here is the base here equals the base to the exponent equals the argument, right? Well, once the bases are the same, what happens to the exponents? They're also the same, right? This one's an x and this one's a 1. So guess what x equals? 1. So what do you think this equals? You think it equals 1 every time? What if the b in this case was a 5? Then it would be 5 to the x power equals 5. Wouldn't x still equal 1? What if b was 23? 23 to the x power equals 23. So when the base and the argument are the same, the answer is 1. Tell me again what you just told me on this property up here. What happens to this? In the front as a multiplier. What did you just tell me was the value of this? That equals 1, doesn't it? What is p times 1? That's a p, isn't it? So those are some good special cases. And let me tell you what some people remember. They remember that if the base and the argument are the same, the answer is the exponent. Is that a good way to think of this? What about if it's this one? If the base and the argument are the same, is the answer still the exponent? Yeah. Yeah, it is. Okay? Any questions so far? Those are the 3 major log properties that we're going to talk about today. So let's do some sample problems together to see if you've got this. Fair enough? Okay. So let's start right here with A. It says first try these without a calculator. And we're going to follow those directions. Then we'll check it. We'll use a calculator to check in just a moment. Okay? What do we do to these 2 arguments to get this argument? Multiply. Isn't 450 times 2 equal to 900? So what do we do with these 2 answers then? If I multiplied these numbers, what do I do with these numbers? Add. 2.95. Done. What did I do with these 2 arguments to get to this one? Multiply. If I multiplied these 2 numbers, what do I do with these 2 numbers? Add. 1.82. Is that what you said? Done. What'd you do with these 2 numbers in the argument to get to the new argument? Oh, we divided. So what do we do with these 2 numbers? Subtract. Done. What's the comment I usually get right here? They can't all be this easy. All I'm doing is following the properties, aren't I? Can they be this easy? Yes. What about this one? Uh-oh, there's only 1. See, here's the hard one, right? How do I get from here to here? You square it. So, you mean like if there was an exponent right here? Then what does that become? The multiplier times this. Done. So you think it's hard until you think, and then you got it, right? So letter E asks, oh, we didn't ever check these with a calculator. Did any of you check these as we went? Okay, somebody choose one of these and go back and check it. Make sure that we did our math correctly. It's important to check. Who's got A? Who's got B? You got B? C? D? Okay, what you got? Which one's right? D is right. C is right. I need A and B done. A is right. B, thank you. Anybody else got A? That's right. Okay. You good so far? Okay. So let's take a look at E. Rewrite each as the logarithm of a single expression. What? What does that mean? How many times do I want to write the word log? Once. Okay? If I am adding these two logs together, what do I do with their arguments? Multiply them. Does anybody know what 2 times 5 is? 90. That's close. And what I meant by close was not right. Okay, I know. Okay, if I'm subtracting these two logs, what do I do with their arguments? What is 500 divided by 5? 80. Okay, also close, but not right. You guys are joking with me today. Good. What about G? I'm subtracting the two logarithms. What do I do with their arguments? I would divide. Do you happen to know what x divided by 10 is? Neither do I. Log. Is that a 5? Log base 5 of x over 10? Done. The base does not change. We do not mess with the base. Because why? It's all about the base. I think that would be a good song, personally. Okay. What about H? Wait, are we done on this one? Can we do anything else? No, we can't do anything else because we don't know a value for x. So yes, we do just have to leave it like that, and that's okay. Okay? Which other one? Yeah, both of these two, we just leave them because all it asks us to do, it doesn't say solve it. It just says rewrite it as a single expression. Okay? Good questions. What about H? What happens to that 2? Where does it go? It goes up here as an exponent on the argument, right? So first of all, I get log base 3 of x plus 1 squared, except I can figure that out, can't I? Log base 3 of x squared plus 2x plus 1. Uh-oh, I got some looks. Where did that come from? X plus 1 times x plus 1, distribute, 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 distribute. Remember that? We only did that 85,000 times a couple chapters ago. Yes? Okay. What about I? What happens to this? Exponent on the argument, right? So I have log of 8m to the 12th. I see erasing. What happened? Did you put 2 or did you put 7? Put 2? Okay, that's right. You just forgot that everything is being raised to the third power and not just the variable. Okay? 2 to the third power is 8, and m to the 4th to the third power. Remember, when we have a power to a power, we multiply those numbers, yes? Any questions so far? Okay, then let's look at the last 4 here. Simplify each expression. Okay, it's not asking us to rewrite it. It wants us to get it in the simplest forms as possible. So tell me, what J is. 7. The person that said the answer did not touch her calculator at all. How did she know it was 7? The base and the argument were the same, so what's the answer? The exponent, right? So what about K? 1? Why is it 1? The base and the argument are the same. The answer is the exponent. So what about L? Somebody said -4 really fast. Except I don't see any base. Oh, I forgot about that. It's an understood 10, right? The base is a 10 if it's not written. So are the base and the argument the same? Yes. So then the answer is the exponent, right? Okay, what about M? We have to write it as a single expression first, don't we? So when we do that, we get log base 12 of, if I'm adding these two logs, what do I do with their arguments? Multiply. What's 3 times 4? And so 1, because the base and the argument are the same, the answer is the exponent. Yes?
Do you know how cheap you get when that headset goes on?
You have 7 problems to do. These are your practice problems. Ask as you go. I do have the answer key pulled up on my screen, so you can come and check as you go as well. Any questions?